will try to enunciate clearly, okay? All right. Okay, so the main idea today is actually quite a bit shorter than all of these notes. So let's just get through like the main part of today. The goal today is to first make sure you understand what this thing called hypothesis test is. In short, it's a decision about whether or not you think something that somebody claims is true. Okay, if somebody claims, like if we're talking lunch line, and there's three main sections in the lunch line. There's the burrito bar, and then the, I don't know, I guess there's four, but we'll just go with three, and then the snack section, and then the hot meal line. Okay, so let's go with that. So let's say that I say the probability of the burrito bar is 33%. Okay, well, somebody claims this. This could be a claim. So if this is a claim, and we get it to behave normally because we take samples and follow the conditions and so on, how could I dispute this claim? How would I come up with evidence to be able to reject that and say 33% of people do not go to the burrito bar? How could I do that? Good. If you take a sample and it ends up being more than 2 standard deviations away, so if your sample is out here, then you would have evidence to say to the whoever thinks this, no, this is not correct because I got something so far out that it's it's an outlier. It's statistically unlikely if 33% is true, so 33% must be wrong. I reject your claim. That's a test. That's what we're doing. All right, so now the first thing you have to do, though, is get an idea of what this thing called null hypothesis and alternative hypothesis statements are. So that's what we're going to do first. Let's jump to problem number 1. Okay, census data for a certain county shows that 19% of adult residents are Hispanic. So since that was taken from a census, that's fact, okay? That's a done deal. 19% are Hispanic. Now, suppose 72 people are called for jury duty and only 9 of them are Hispanic. All right, so only 9 of them. What is this stuff telling me? What's this second sentence saying? 72 people are called. What's that? No, that's your sample size, okay. And what's this 9 out of 72 representing? Okay, so the sample results that you got were 9 out of 72. And so we're wondering, does this p-hat, which it is lower than 19%, call into question the fairness of the jury selection? If jury selection was fair, what proportion of the jury selection people would be Hispanics? If jury selection was fair, what proportion of the jury selectees would be Hispanic? 19%. Why? Because that is what the population of the county has. So that's what we're wondering. Is does the jury selection have 19% Hispanics, or can I reject that claim? All right, so in order to do that, we're actually going to go to the next page, and we're going to only do today this top part. It's very important that we totally understand the parameter and the hypothesis statement, so that's all we're doing today. All right, you can see on your notes that it actually says that define the parameter of interest for the situation. So what are they talking about? The same problem. It's the same problem with the number 1. Okay, the fairness of the jury selection. So how do we know if it's fair or not? What value tells us that? If what is 19%? Okay, yes, you're getting there. That's it. Okay, so we have to identify if the proportion of jury selectees, so those selected for jury duty, the proportion of jury selectees that are Hispanic. Okay, now this is like we're making a claim about all jury selectees, not just one sample we took, all jury selectees. Before we go on to the hypothesis statements, I want to just show you one quick little thing to consider. Look at these two statements. Consider these two statements. The proportion of Hispanic residences on the jury selection versus the proportion of the jury selection group that are Hispanic. Those two sentences mean two different things. You don't have this, but we're just looking up here. What's the difference mathematically between them? Yes, the bottom thing, which is the denominator. Good. The top problem, the proportion of the Hispanic residences that are on the jury. What's the denominator? Yes, the denominator of this one is you're just going out of all the Hispanic residences, what proportion of these, or how many that are of these Hispanics are on the jury. Yeah, Hispanic, thank you. Hispanics on the jury. So out of all the Hispanics, what is the Hispanics on the jury? How many are on the jury? Okay. Next, what about this one? Proportion of jury selection group. What's that one? Okay, good. Out of all the jurors, what proportion are the Hispanic jurors? What are we talking about here? Which one of these? This is the one we are talking about. It's critical. This is not right. We're not just pulling out of only Hispanics. No, we're pulling out of the jurors. What proportion of the jurors are Hispanics? So watch your language on that, okay? It makes a difference how you state that. All right. Now, the hypotheses statements. The first one we're going to start with is this thing called null hypothesis. Okay? So the null hypothesis is always about the claim. And it is always an equal to statement, period. Always, always, always. So this problem would look like this. Okay, you would draw H with the little O. That little O represents null. So this is the null hypothesis statement. Then you do a colon, and here it is. Capital P is equal to 0.19 Hispanics. Because that is the claim about the proportion of the jurors that are Hispanic. That's the null hypothesis. Okay? The next thing is alternative hypothesis. Alternative hypothesis. What would give us, if we end up rejecting, then what's our conclusion? If we end up rejecting the null, what do we then conclude? And you get things such as less thans, greater thans, or not equal tos. These are symbols that are always less than, greater than, or not equal to. So here's how this one looks. H with the little a, which stands for alternative hypothesis, and then a colon. And in this case, we are wondering if the Hispanics are being underrepresented. So what sign would we be looking for? P is less than 0.19 Hispanics. So what happens is if we get a sample that is more than 2 standard deviations below the mean, we will reject the null and have evidence to reject it and conclude that the alternative is true. And that's where we're headed with this week. But all we're doing today is that much. So if you would, turn to page 26 in your packet, because your homework is 26 and 27, of which we may get quite a bit of that done today. Let's look at the first one. Okay? So on this page, on each problem, you're going to do 3 things. Number 1, write the parameter that we're looking for. Number 2, put the null in the alternative hypothesis. Okay, so you have 3 things on there. That's it. Here's the first problem. A shipment of parts has arrived, and you are the receiving person who decides to take the shipment or not. The company that the parts shipped from say that the specifications for the parts in the shipment show an average length of 2 inches. All right, so what's the claim here? What's the claim about? I guess that's what I should say. What's the claim about? Okay, not only just the length, but the average length of what? Of all of the parts on the shipment. Okay, it's very important that you really make sure that it is clear you are talking about the population of the whole shipment. So do you see this lowercase mu, lowercase u? It's a mu. Do not put an m. That was very annoying when I was reading some tests. Some people were putting just a regular old m there, and that's not what goes there. It's a lowercase mu, cursive u, equals the average length in inches of the parts on this shipment. So it's all the parts on this shipment. You do not have to put this, but if you put the word all in there, then that would be great, because this is commonly a common mistake with this thing is that people talk about the sample instead of the population. Whatever you can do to make sure that it is noted that this is about the population of the whole shipment is good. All right, so what would the null hypothesis be? That the claim is that the mu is 2 inches, okay? So that's how you would write that. Okay, and then the alternative would look like what? It's not equal to, because we do not really have an indication that I'm worried they're too small or I'm worried they're too big. I just am worried if they are not meeting specifications, okay? So either too small or either too big, both are bad. So either direction will reject their claim. That's it. That's all we do for each one of these problems. So let's look at number 2. We have a carburetor, which is a part of a car, and it causes the car to get 24 miles to the gallon. But we now claim that we can make one better. All right, so what would we be hypothesizing about? If what's right, you said if it's greater than da 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 da, it is the key word. That's what I'm looking for. What does it mean? Okay. Yes, right here. Your parameter always starts with the word average or proportion. In this case, the mu is the average miles per gallon for a car with this carburetor. I mean, and if you were really, really good, you could say for all cars, you know, for all cars with this, to really emphasize it's about the population of all cars. So I'm going to take a sample and then generalize to all cars that have this carburetor. All right, so the null hypothesis would be that the average is 24 miles per gallon, and the alternative that we would be looking for is that it's what? They claim we make one that's better. What would be better? Greater than 24 miles per gallon. More miles per gallon is better. Okay, so in this case, maybe you are the maker of the new carburetor, right? Maybe, and you know what you're hoping? In this case, the average is at 24, but you are hoping that you get a sample up here, because you actually, if you're the maker of the new carburetor, you actually hope that you can reject the null, because then that would say your carburetor is doing a good job. Okay, so sometimes you want to reject it and sometimes you don't. It's not necessarily a bad thing. Okay, but we would reject the 20.24 if we found a sample above 2 standard deviations on the high side. Okay, so I want you to take a minute and do number 3 and 4. Go ahead and do 3 and 4 right now. Try it. Okay, I want to go over this real quick. You may not be completely finished, but what did you get for the first one? Hey, Make sure you are starting with this word average. Don't say the ounces, the number of ounces in the 2-liter bottles. No. Mu is the average for all of the bottles of soda from this manufacturer. I think if you didn't have this part right here, it's no good. It's from this manufacturer, not all 2-liter bottles ever. Okay? So if you didn't have this word average, I would mark it not correct. I would mark it wrong. I need to know that it's from this manufacturer. This is probably, debatable. It's good, but I probably wouldn't mark it wrong if that wasn't there. I think you could handle not it being there. And so, of course, your null is it being equal to 67.6, and your alternative is it being less than because you were afraid you were not getting enough. And then for number 4, your mean is, do not forget to start your things with average ounces of Kisses per bag of all the Hershey's Kisses bags. I would say all is probably not required here. It kind of leaves a little question, but it makes it well known that you know you're talking about the population if you put that all in there. And of course we got equal to and not equal to. Now turn over to number 6 because I think this one's going to get you. The next one is another average, but I'm going to tell you straight off the bat, number 6 is a proportion problem, so I want you to read that one and see what you can do. Key point here, use symbols such as capital P, not mu. And don't use the word average, use the word proportion. Okay, so this one's going to be P equals what? Proportion should be the first word you write down. P equals the proportion of defects in the CD manufacturing by robots. Maybe I should put all of these robots or something, but anyway, it's these particular robots. Okay, and then the null is P equals, and you can leave it as a fraction or a decimal, and the alternative is P is less than. Okay, so my point is keep track. P's for proportion and mu's for average, and use those words as the first thing in your problem. Okay, so you're to finish this, which isn't much left, but then also make sure that you get started on that project so that you can go meet with somebody if you need to ask them questions.